Chain rule differentiation. The chain rule is used to differentiate expressions of the form y equals g of u, where u is some function of x. And the chain rule breaks down to dy by dx equals dy by du multiplied by du by dx. So what does this look like in practice? So this is best illustrated with an example. So if you have, say, y equals 2 multiplied by 17 minus 4x cubed, all cubed. This is a typical example of the type of expression that you differentiate using the chain rule. And the first step to differentiating this will be to say, let u equal 17 minus 4x cubed. So now that means that y equals 2 multiplied by 17 minus 4x cubed, or u cubed. Then what you have to do is differentiate both of those expressions. So if u equals 17 minus 4x cubed, then du by dx equals minus 12x squared, and dy by du equals 6u squared. So then applying the chain rule, which states that dy by dx equals dy by du multiplied by du by dx, which equals dy by du is 6u squared multiplied by du by dx, which is minus 12x squared. So dy by dx now simplifies to 6 multiplied by minus 12 is minus 72 u squared x squared. But now we need this all in terms of x, so we look back and see what u was, and u is 17 minus 4x cubed. So dy by dx equals minus 72, and then 17 minus 4x cubed, which is u squared x squared. And then finally, simplifying this, so dy by dx equals minus 72 x squared multiplied by 17 minus 4x cubed squared. But I think of this as the long form of chain rule differentiation. There's a short form method, or chain rule shortcut, as I call it. And when the exams are very time pressured, so if you're pressed for time, there's a much faster method of differentiating expressions like this. And the key to this is thinking of these expressions as being in this form. So if y equals a multiplied by some function of x to the power b, then dy by dx equals a multiplied by b, ab, multiplied by the function to the power b minus 1, multiplied by f of x differentiated, or f dash of x. So applying this to the same example as before, so say if y equals 2 multiplied by 17 minus 4x cubed, all cubed, then here a equals 2, b equals 3, and f of x equals 17 minus 4x cubed. So dy by dx equals ab, so that's 3 times 2, which is 6. F of x, 17 minus 4x cubed, to the power b minus 1, or 3 minus 1, which is 2. And then all of that multiplied by the inside of the bracket differentiated. So this inside the bracket differentiated, which is minus 12x squared, close brackets. And then again, simplifying. So 6 multiplied by minus 12x squared is minus 72x squared multiplied by 17 minus 4x cubed squared. So the difference there is that this took 3 lines of working versus a lot more using the more traditional form of the chain rule. So this shortcut chain rule method is particularly useful when you're dealing with differentiating an expression that would need you to combine the product rule and the chain rule. So I have an example of that here. So say if you needed to differentiate something like this. So y equals 5 multiplied by 2x cubed minus 8 to the power 4 multiplied by e to the power 9x. So here you have one function, 5 brackets 2x cubed minus 8 to the 4, multiplied by another function, e to the power 9x. If you were to use the more traditional long-form chain rule differentiation method for this, then it can become very confusing and you'll have lots of dy by du's by dx's all over the place, and it all looks really confusing. But if you use the shortcut method, it's a lot simpler and it's a lot faster. So what I would do here, the first thing I would do, I would say, because this is product rule differentiation, so you have u multiplied by v. So you first off need to say that u equals 5 brackets 2x cubed minus 8 to the power 4, and then v equals e to the power 9x. And the product rule is this. So when you're multiplying a function multiplied by another function, or u multiplied by v, then dy by dx equals v multiplied by du by dx plus u multiplied by dv by dx. So here I've said that u is 5 multiplied by 2x cubed minus 8 to the 4. So differentiating that, I'll just write it again. Write it again underneath. So u equals 5 2x cubed minus 8 to the 4. So this is where we use the short form chain rule differentiation. So du by dx equals, so ab, 5 times 4, 20, multiplied by the function inside the brackets, unchanged, to the power of this power minus 1. So 4 minus 1 is 3. And then that multiplied by the inside of the bracket differentiated, which is 6x squared. And that can be simplified to du by dx equals, so 20 times 6x squared is 120x squared, 2x cubed minus 8, all cubed. Okay, so now to deal with v. And v was e to the power 9x. So if v equals e to the 9x, this is much simpler to differentiate. So then dv by dx equals 9e to the power 9x. So now, applying the chain rule to this, applying the product rule to this, so dy by dx equals v du by dx plus u dv by dx. So just going back up to see what v and u are. So v is e to the 9x. So this equals e to the 9x, which is v, multiplied by du by dx, which is 120x squared, (100 120x squared multiplied by 2x cubed minus 8 cubed plus u, which is 5, 2x cubed minus 8 to the 4, multiplied by dv by dx, which is 9e to the 9x. So that's multiplied by 9e to the 9x. So then dy by dx equals e, change that, just simplify that. So that is 120x squared multiplied by e to the 9x, which you can write as 120x squared e to the 9x multiplied by 2x cubed minus 8 cubed plus 5 multiplied by 9e to the 9x is 45e to the 9x multiplied by 2x cubed minus 8 to the 4. So there we have it. So that's a combination of product rule and chain rule, but greatly simplified because we're using the chain rule shortcut instead of the long form version of the chain rule. So I hope you found this helpful, and if you did, then please like and subscribe, and I'll see you next time.